Two triangle theorems you already know. Exterior angles bigger than either of the two remote interiors. And then second half of class on Wednesday, we said, oh, in any triangle, biggest side is always across from biggest angle. Here's a third one today, and probably the most important one, I think, is I hate to break it to you, and nobody ever told you this, but when you have a triangle, and if I say to you, give me 3 side lengths, you just can't give me any 3 you want. Okay? You give me 3, 6, and 20, that's not a triangle. All right? It's not a triangle. It has to follow a specific rule, which you and your group are going to find right now. Okay? It has to follow, it cannot be any 3 sides you want. It will not form a triangle with 3 sides. Okay? So here's what we're going to do. Big group activity today. Define that rule for me. If you start reading them, if you start reading the directions today's group activity, you will see the following. Please be quiet. You will see the following. Each member of the group should take turns picking 3 straws. What class are we in? Honors. We don't roll with straws, all right? We're going to roll with licorice today, all right? As I put the licorice on your desk, please act like you've seen food before and not be animals. All right? We're going to have to use these before you eat them, please. All right? I'm going to put licorice on your desk. This is your job right now. You are going to make 2-inch pieces, 1 2-inch, a 3, 4, 5, and 6-inch piece. Correct, yes. All right, so I want a 2, a 3, a 4, a 5, and a 6-inch piece before we go to the next step. And just leave them on your desk. How you cut them, I don't care. All right, how you cut them, I don't care. Why are we always getting up? Stay in your darn seat. Okay, let's get the job done. Two through 6-inch pieces. Whether your group's ready or not here, here's what your next task is. You are going to take 3 of the pieces, record how long they are, and then you're going to try to put them together to form a triangle. Now, this is what I mean by form a triangle, meaning it's got 3 vertices. It doesn't have an exterior angle. It doesn't come up short. Don't try to stretch the licorice. All right, it's got to form a triangle from vertice to vertice. If you and your group are having disagreement, please call me over and I will let you know if it should or not. All right, I would like you to find a couple yeses and a couple nos here. All right, just not all, they're not going to be all yeses and all nos. All right, so go ahead right now, take 3, record them, see if it forms a triangle or not. Find a couple yeses and a couple nos. Any disagreement, call me over. So you guys just noticed too, you can't have any 3 sides you want because you got a couple no's. All right, first let me start with a couple yeses, just a couple. Ryan, what was one triple that was a yes? 3, 4, 6. Yep, that should have formed a triangle. I got another one. Go ahead, Caitlin. 2, 3, 4. Absolutely. Should have formed a triangle. And can I get one more triple? And then I'll go to the nose. One more triple that worked. I got 3, 4, 6, and 2, 3, 4. Should have been more. Yep, Al. 3, 5, 6. Yep. That's a good one. All right, let's go to the nose now. Give me a triple that did not form a triangle. A triple that did not. Go ahead, Grace. 2, 3, 5 should not form a triangle. And how about one more that did not? 2, 4, 6. That's a good one. All right, let's talk about our results because there's a pattern here. All right, when it does and versus when it does not form a triangle. And some of you started talking in your groups. Why not? All right, let's take a look. 3, 4, 6 were good. 2, 3, 4 was good, but 2, 3, 5 was not good. Either was 2, 4, 6. All right, quickly discuss about 30 seconds in your group. When can I form a triangle? What do I need to know about the sides? All right, here we go. Ready? And I don't need an exact wording of this theorem. Any group want to try it out on me? It's going to form a triangle if the sides, something about the sides. Meg? What about equal to? Is that going to be okay? Can it be equal to the longest side? Yes. Here's what the theorem says, and we'll write it down in a second. The sum, meaning I have to do what? Add. The sum of two sides always has to be bigger than the third. Not equal to, bigger than the third. All right? Notice what happens. 2 plus 4, not good. All right? That's not bigger than 6. All right? So the sum of two sides, and that's called the triangle inequality theorem. In a triangle, sum of two sides is greater than the third. Right. So that goes right along with the biggest side across from the biggest angle yesterday. All right, let's just go through. Let's use it now. Let's use this theorem. On number 1, just so nobody gets embarrassed, I've had in years past, this is not a multiple choice question. All right, it's not a multiple choice. I know you see 1, 2, 3, 4, 5. Maybe it's multiple choice. No, we're going to go through each of them right now, and I need you to tell me if it's a triangle or not. If it's not a triangle, back yourself up and tell me why it wouldn't work. All right, so I have a triangle of 1, 2, 3, side lengths of 1, 2, 3. Good enough for a triangle? Yes or no? Here we go. 10. Start us off right. Yes or no? No. Why not? What doesn't work? 1 plus 2 is equal to 3, not greater than 3. Now, hey, I know some of you may say, hey, but what's 3 plus 2? 5. That's greater than 1. But as long as there's one that doesn't work, that's all I need to say a no. All right, as long as there's one pair that doesn't add up to the third side or is greater than the third side, that's all I need. How about 2, 4, 5? I know this is from your licorice one here, but 6, 2, 4, 5? Oh, yes. Yep, that works. How about 5, 5, 6? 5, 5, 6 work? 14, 5, 5, 6? Yes, I'll even take this a step further because we're in honors. What type of triangle is this? Isosceles, yep. That's a good isosceles triangle right there. How about 8, 13, 21? 8, 13, 21. 28? Nope, why not? 8 plus 13 is 21. It's got to be greater than that third side. And then finally, how about 10, 20, and 25? 10, 20, 25. What do you got, 30? Yes. Yes, nice job. All right, so we can determine if it's a triangle or not. The other part of this is using that theorem, you got to tell me possible lengths of a third side now. Possible lengths. So if you take a look at the next one, it's telling me I got 4 and 7 as side lengths. What are possible lengths of the third side? And remember, it can't be any number. You guys just found that out on your licorice. Cannot be any number. All right, it's got to follow our rule. So let me just draw this out here because this first one's going to take a while. So I got 4 and 7. What are possible lengths of that third side? All right, good. Just want to make sure. Just give me lengths here. Good, Connor. Well, why don't we start listing them out? 5 work, everybody? Okay, 5 works. Another example? 4. Does 4 work? Yeah, 4 works. Colin? 6. Grace? 12. Would 12 work, though? What's 4 plus 7? 11, right? It's got to be greater than... So 12 wouldn't work because 4 plus 7 is not... What's that? 10? 10 would work. Roman? 7. Can we just fill them in here? 8, 9. Can I keep going to 11? No, can't go to 11 because 4 and 7 is equal to 11. But I hate to break it to you, I don't have time for this, for you to list them all out like that. And plus, what if there's a huge gap between the side? What if it's, a side of 2 and a side of 20? You're going to list all those out? Probably not. So what I want to do is list these as an inequality. All right. Last year, I hope anyway, you probably covered what was called a compound inequality, which is 2 inequalities. It's between this and x is between this number and this number. Sound familiar? That's what I want to do here now. All right, is represent these sides as a compound inequality. All right, so what I'll do is I'll put S in the middle. And now most of you probably think I'm going to do this. And that's good enough, but it's not. It's not good enough. Here's why it's not good enough. Ready? Does that work as a side length? Does 3.7 work as a side length? Well, what's 3.7 plus 4? 7.7. Is that bigger? So that works, but is that in inequality? No, that's not there. So I need to adjust something here. I need to adjust something because I have 3.7. You told me it works, but it's not in between my inequality here. So I need to adjust that inequality somehow. So every possible side length is included. What do you got, Colin?
You need to just make it greater than n equal to instead of greater than or equal to.
So you want me to just remove the or equal to's but keep 4 and 10?
No, change it to 3 and 11.
Okay, so you want me to get rid of the or equal to, you're telling me, and replace the 4 and 11 with?
3 and 11.
How's that look? Do I have 3.7 in there now? Why did I have to take away the or equal to? Because if it's 3, what's the problem if it is 3? 3 plus 4 is 7. It's got to be greater. So everyone all right with the inequality? Okay, now that took us a while. And I don't want to keep doing this over and over again. All right, and I know it may have got confusing because I drew this, I drew this out and out and out. What sides did I give you to begin with? What were the original 2 sides? 4 and 7. Look at our beginning and end value on our inequality, 3 and 11. Is there anything you can do with the original 2 sides to go like that to the inequality? How can I go from 4 to 7? How can I use 7 and 4 to go to 3? Subtract it. How can I use 7 and 4 to go to 11? There you go. There's the quick way out. That can tell you your end and your beginning and end values of the inequality. So for number 3, if I have 9 and 17, I don't want to have to list all these out again. All right, 9 and 17. My side length should be in between 8, 17 minus 9, and 26, 17 plus 9. And then 11 and 20. Yeah, see, I don't think anybody wants to list out all the ones between 8 and 26. We're not doing that. How about 11 and 20? The sides have to be somewhere between 9 and 31. Questions? And yes, anytime I can put it into a problem, I definitely am. Let's graph it and figure out if this is actually a triangle or not. And I'm not going to accept, yeah, it's a triangle because I can connect everything. That's not mathematically proving it. All right, if this is going to be a triangle or not, I need to know the side lengths so I can tell if the sum of two sides is bigger than the third side. So how do I find the side lengths? Distance formula. And just so we can go a little bit quicker and you guys can get a jump start on your homework. Let's see, I'll assign QR to this 3 right here, these 3 groups right here. QR, I'll assign RS to these 2 in the middle right here. And the other 3 on the end over there, you guys have QS. Simplest radical form, because you are in honors. If possible, if possible. Remind each other of the distance formula if someone in your group needs reminding.